Okay, so we left off last time and we were talking about section 5.1. I want to do a couple more examples in your additional notes because I've had a lot of people coming up to me and asking questions about the homework. So go ahead and flip to your additional notes. We'll do a couple. Let's do this one. So 8x to the negative 2, y to the fifth, all over 10x to the negative 3, x to the fifth, y to the negative 7. Okay, there's lots of different ways you can do these problems. So the first way that we talked about was switching anything that was negative and putting it in an opposite location and making it positive. So you can do that. I'm going to show you that method. So the things that would stay would be the 8, the 10, the x to the fifth, and the y to the fifth. Everything else had a negative power, so they're going to go to the opposite location. So instead of having x to the negative 2 on top, I'm going to have x squared on the bottom. Instead of having x to the negative 3 on the bottom, I'm going to have x cubed on top. Instead of having y to the negative 7 on the bottom, I'm going to have y to the 7th on top. Okay, the benefit of doing it this way is it just looks a lot easier. It makes more sense when you do like the subtraction rule or when you think about it logically. There's no negatives there. Matthew, do you have a question? Yeah. Like, how did you get that? Like, why can you do that? Okay, so why can you do that? So let's say I had, let's do something off to the side. If I had x to the negative 2 on the bottom, then what that is, and let's say I had y to the negative 3, or sorry, x to the negative 2 on top and y to the negative 3 on bottom. So let's say I have that. Do you guys remember the rule that says that x to the negative 2 is 1 over x squared? Did you guys get that? And y to the negative 3, what's that? 1 over y cubed. Okay, so what you have right there is 1 over x squared divided by 1 over y cubed. So when you think about the rules for fractions, if I had a fraction divided by another fraction, I always write it with like the obelisk sign. It's called an obelisk. I always call it the old school division sign. So if I write it like that, I have 1 over y cubed. So what happens? If I'm dividing by the fraction, what do? Multiply by the reciprocal, right? So I have 1 over x squared times y cubed over 1. So do you see now the y cubed is on top and the x squared is on the bottom? Okay, so that's what's happening there. When you had 1 over x squared, that's putting the x squared on the bottom. When you have y to the negative 3 on the bottom, it's putting the y cubed on top. It's switching the positions. Does that make sense? Okay. Can I erase the rest? Okay. All right, so that's why we're allowed to switch the positions when we have negatives, negative exponents. All right, so now we just kind of simplify. So I look for common terms. I have, first let's start with the numbers. I have 8 and 10, and those reduce down. So they're both divisible by 2, so I'd have 4 fifths, just like before. Let's look for the y's on top together, and then I also have x's on the bottom together. So let's simplify there first. So I'm going to have 4x cubed y to the fifth times y to the seventh, so that'd be like there's 12 y's lined up next to each other. So y to the 12th, all over 5x to the 7th. And one last step, do you guys see what we need to do? Yeah, the x's. So think of if I had 3 x's along the top and 7 x's along the bottom. 3 would cancel with 3 on bottom. I'd have 4 left on the bottom. So that's going to be x to the 4th on the bottom. So I have 4y to the 12th all over 5x to the 4th. And that would be your answer. Okay, so that's one way. The next way is to use your subtraction rule. In order to use this subtraction rule, you would need to at least combine what's on the top and the bottom already. So let's start out with what I had to begin with. So anything that's on the top that are like terms that have x's or both have y's, we're going to combine. So see how on the top I only have one thing that has x and one thing that has y? So that's as simplified as the top's going to get right now. But see how on the bottom you could combine your x's? So you get x squared on the bottom. Let's still reduce our numbers and make it 4/5. So I'd have 4x to the negative 2, y to the 5th, all over 5x squared, because I add my exponents, y to the negative 7. Okay, then you use the subtraction rule. And with the subtraction rule, your end result, you always write on the numerator. Okay, then you can deal with the negatives after that. So my subtraction rule would be, I would still have my 4/5, my numbers stay the same. For these powers, I'd have negative 2 minus 2. So I'd end up with x to the negative 4. And you always write it on the top. Okay, then my y's, I would have 5 minus a negative 7. So that's 12. So I'd have y to the 12th. Okay, then your last step is to deal with whatever negatives you had. Okay, so see how you had x to the negative 4? You would put that on the bottom now and make it x to the positive 4. So you'd end up with 4 over 5x to the 4th, and then the y to the 12th is still on top. So see, you have the same thing. Okay, you kind of have to just choose which method you like better. If you like moving the negatives around, you can do that. If you don't like that, use the subtraction rule. Okay, and then the last thing, Mr. Cyrek showed me, he did something like this when he taught algebra. So let's say we were at this step right here. So I had simplified kind of on the top and the bottom. So I'd have 4x to the negative 2, y to the 5th, all over 5x to the 2nd, y to the negative 7th. Oh gosh. And he doesn't move all of them. This isn't a good example for this. He just moves whichever one has the largest absolute value. So this is the largest absolute value. The absolute value of negative 7 is 7. So he'd move that to the other location. So he'd move it up here and it'd become positive. So then he'd have y to the 12th. I know, it's confusing. I need another example that's better than that. All right, and then this one he can move to the bottom and become x to the 4th. Okay, I'll do another one where we might see that, where we can use that. Okay, so you want to try one more?
If one of our actual real numbers is a negative, should we not make it what if we have negative 4x?
Yeah, if you have negative 4 out front, so let's do one like that, then that's not an exponent. So only negative exponents you move. Yeah. Okay, so let's say I have, I think you just had a negative on your example. You just had a negative out front on one of them. But let's say we have negative 4 x to the 3rd, y to the negative 5, all of that to the negative 3, all over. He's in the zone. He has no idea she's standing right there. 16x to the 5th.
Sorry.
Y to the negative 8. Okay, so let's say I have that. Messy. Just like Mr. Cyrek.
That's not that loud. I can still hear you kind of as a murmur.
All right, so let's say we have this. Let's make this positive 3. That's just going to be way too much stuff on the bottom. Okay, so what would we do? Any ideas? Okay, so let's bring the 3 into every single thing on the top. So when I do that, my new numerator be careful. The negative 4 is being raised to the third power. You can even think as the negatives being raised to the third power individually. So if the negative is being raised to the third, that's negative 1 times negative 1 times negative 1. So you'd have a negative in the end, right? So we're still going to have a negative. What about the 4 to the third? What's 4 to the third? No one knows it. 64. You'll see that a lot. You should know it. All right, how about the x's? What's that going to be? No, not to the ninth, right? You multiply your powers. So x to the ninth. And again, if you need to, think of x cubed cubed. That would be x to the third times itself 3 times. So think about how many x's you would have lined up when you expand it. You'd have 9 total. And then I have y to the negative 15 all over 16 x to the fifth, y to the negative 8. And let's bring this squared in as well. So the squared goes to each piece. So 2 squared is 4. X to the fifth squared is x to the 10th. And y squared is just y squared. So far, so good? Okay, now let's combine anything that's the same. So if we have 2 x's on the top, combine them. So the top's good. But let's combine our x's on the bottom and our y's on the bottom. So I have negative 64, x to the ninth, y to the negative 15, all over 16, x to the 15, y to the negative 6. So I just add their powers. Did I mess something up? Oh, and the 4. Okay. So times 4. Okay, so what is 16 times 4? 64. See how nice I made that for you? So 64. All right, now combine your x's and y's from the top and the bottom. So you can do either method you want. If you like the subtraction rule, remember you always write it on the top. So if I just subtracted my powers, I would have x to the negative 6, and I would write that on the top. Okay, or you can think about which one's bigger. So the x to the 15th is bigger. So that means that I'm going to have more x's on the bottom. Okay, 64's just cancel, so I have a negative out front. It's going to be over x to the 6th. What about the y's? Yeah, you can like switch their positions if you want, or you can do your subtraction rule. So I have negative 15 minus a negative 6. So that would be negative 15 plus 6. So that's negative 9. So that means I would basically have y to the negative 9 on top. So where's my y in the end? On the bottom. So you really have y to the positive 9th on the bottom. Okay, so if you don't like that way, think about if I had y to the negative 15 over y to the negative 6, switch their positions, right? They're both negative, so the negative 6 is going to go to the top and become y to the 6th. The negative 15 goes to the bottom, becomes y to the 15. Now do you see why it's y to the 9th on the bottom? Okay, so that's your answer. Notice that negative out front isn't an exponent. It doesn't mean you switch their positions or anything like that. It's just a number, so it's just pulled out to the front. Okay, you guys feeling better? Do you want to do any more of these? Or are you good?
Can we do one with like when you're multiplying 2 of them?
When you're multiplying 2 of
Like,
them. Oh, I see, okay.
our homework, like,
Yeah, I got you.
have like 2 in parentheses next to each other.
Yeah. Okay, what's 11?
Let's do that one.
With a negative? Let's make it really hard. So like that. Okay, so if I have 4f g to the negative 3 all over 8f to the negative 2 g to the 5th times 2fg to the third, all raised to the negative 2 power. So first of all, when you see something raised to the negative 2 power, how can you get rid of that negative 2 power? Take the reciprocal of the base, right? Do you guys remember? So we're going to take the reciprocal of the base. So even if that had been a fraction, you would just flip the whole fraction. So anything in it, including negatives, everything would just reverse. So I would have 1 over 2fg to the third, and now it's going to be raised to the positive 2. Okay, this other one we can try to reduce. The 4 and the 8 reduced to 2 on the bottom. Yep. So I have 2. What method do you guys like? Do you like to move the negatives, or do you like to do the subtraction rule? How many of you like to move the negatives? Okay, how many of you guys like the subtraction rule? Oh, just Chris. Straightforward Chris. All right, so do you guys like to move the negative because it makes more sense in the end, like why you have, okay. So let's see. So we have, so I have f to the negative 2. I'm going to move it to the top. G to the negative 3, I'm going to move to the bottom. Everything else stays exactly where it is. So I'm going to have f like I had before, and g to the 5th like I had before. But now my g to the negative 3 is now g cubed on bottom. My f to the negative 2 is now f squared on top. Okay, so that means I have f cubed all over 2g to the 8th times 1 over, I'm going to bring that squared into each piece. So I'm going to have 2 squared, which is 4, f squared, g to the 6th. So combine into 1. Oops, that didn't help me. So I have f cubed all over 8 f squared g to the, what power? 14th, right? Okay, one last step. F's, right? Take care of the F's. So I have f cubed on top, so like 3 f's on top, 2 f's on bottom. So I'd cancel 2 on the top and the bottom. There'd be 1 left. So I'm going to have f all over 8g to the 14th.
Wait, is it G to the 6th or G to the 3rd?
Is it g to the what?
Well, on the right side.
This one?
Is it 4f squared G to the 6th?
Because this 2 right here. Yep. Yep, so it's f over 8g to the 14th. Okay, we good? Caitlin, you good? Did you forget your notebook? Okay. All right, so let's do scientific notations. Let's go back to your normal notes. Okay, hopefully this is all review for you. So once you get to the scientific notation, I think it should be pretty easy. Okay, so the reason we use scientific notation is so that we can represent like really, really huge numbers, like the weight of a planet, really, really tiny numbers, like the weight of a little atom. So it's a way to like write the extreme measurements. Okay, so big numbers are going to have positive exponents, small numbers have negative exponents. Okay, so if I see 1,300,000, my decimal point is on the right side. You count how many steps it would take to go over so that your number is between 1 and 10. Did I skip some? Okay. I must have left it over here. Oh. Okay. So if I have this a value has to be between 1 and 10. And when I say that, it can be exactly 1, but it has to be less than 10. So in other words, 1 is less than or equal to a, which is less than 10. So basically, it can only have one number in front of the decimal point. So you could have 9.99999, but that's because you had 9 point. So one number in front of the decimal point. Okay, n is an integer. So integers are those whole steps, including the negatives. So you could have like -3, -2, -1, 0, 1, 2, all of those. You can't have like 1.5 as your power. Okay, so if I have 3 times 10 to the 6th, that means start with 3. Your decimal point would be here, right? 3 point. And you're going to move that decimal point 6 places so that it gets bigger, because if I have a positive exponent, it's going to be a big number. So I'm going to go 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6 zeros. Okay, so that would be 3 million. Okay, 5.6 times 10 to the 4th. Notice in the last example we had 6 zeros and we had 10 to the 6th. So a lot of people think that it's just the number of zeros you have. But it's really not. If I have 5.6 times 10 to the 4th, that means I'm going to move my decimal place over 1, 2, 3, 4. So you see this one would only have 3 zeros. So it depends on where you started your decimal point. So that's 56,000. So move the decimal place 4 places to the right. Okay. If you see a negative exponent, it means you have a really, really tiny number. So a really tiny number, your decimal place would move to the left, right, and get smaller. So if I have 1.53 times 10 to the -4th, again, that doesn't mean that I have a negative number when you have a negative exponent. It just means you have a tiny little fraction. So in this case, we're going to start with, we'd have 1.53. We'd move it 1, 2, 3, 4. We'd move it to the left 4 places. So there would be 3 zeros out front. All right, and same thing for 9. If I have 9 times 10 to the -3, my decimal place for 9 would be on the right side there. So I'd move it 1, 2, 3. Have you guys all talked about this before? You've all done this before, right? Okay. So we can kind of move quickly. All right, the big thing that people forget is which direction to move. Like, I think some people get so like hung up on right or left or what that you forget how to do these. Like, I just remember a positive exponent is a big, huge number. A negative exponent is a small number. All right, so let's switch back. Taylor, are you with me? All right, so if I have 0.3, you think about where you would move it so that your number is between 1 and 10, not including 10. So you'd move it over 1 place. So that's why it's 3 times 10 to the -1. It's a tiny number, so it has a negative exponent. Okay. This next one, I would have to move over 1, 2, 3, 4 places. See what I mean by don't get hung up on right and left? Because depending on what form you're switching from, it switches, right? This is a big number, so we were moving to the right before, because we were switching from scientific to standard. Okay, so this is 2.5 times 10 to the 4th. We moved it 4 places. Okay, once you get good at these, you can go by threes. 1, so 3, 6, 9, and then 1 more, so 10. So it's 3.89 times 10 to the 10. Okay.
Why is it 0.89?
You always have to use however many numbers it has before it gets to the zeros. So see how it had 3 numbers before the zeros? So you have to use all 3. It's not like sig figs or anything in chemistry. You know how like chemistry, you might only want like 2 numbers in the end or something like that, or you want to round to a certain decimal place. This one you need to keep all the numbers. So if that had been 3, 8, 9, 7, 6, 5, 2, you would have to move it right there. So let's say there were lots of zeros after. So you'd have 3.897652 times 10 to the whatever. You know, you need all those decimal places, which is kind of annoying sometimes. Okay, so the next one you would move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. That makes your number 4.5. That number is now between 1 and 10. So times 10 to the negative 10, because that's a tiny little decimal. So it's a negative exponent. Okay, the next one, how many places do you have to move it? 1. Yep, it's 1. So it's 6.89 times 10 to the negative 1. Okay, so what's really nice about these is if you know the rules of exponents, multiplying with these things is really easy. So you can convert into the standard form and then multiply, but it's easier just to use your rules of exponents. So here, if I have 3 times 10 to the second times 2 times 10 to the fourth, I'm going to do 3 times 2, and then I'm going to do times 10 to the second times 10 to the fourth. So 3 times 2 I know is 6. What's 10 to the second times 10 to the fourth? 10 to the 6, right? Just like x squared times x to the fourth was x to the 6. They have the same base, so you can multiply them. So it's times 10 to the 6th. That's it. Did I say? Yeah, write it in scientific notation. So if I say write it in standard form, then write it in standard form. Okay, next one. So let's get my numbers together. So 1.4 and the 2. Then I'm going to have 10 to the negative 2 times 10 to the fourth. So 1.4 and 2 make 2.8. 10 to the negative 2 and 10 to the fourth makes 10 to the 2. So 2.8 times 10 to the 2. Okay, let's get a little bit harder. Okay, so I have 7.6 times 10 to the 5th times 2 times 10 to the 15th. So I do 7.6 times 10 to the 5th. Oh, no, wait. Let me write my numbers together. So times 2 times 10 to the 5th times 10 to the 15th. So 7.6 times 2. What's that? So 15.2. All right, so I have 15.2 times 10 to the 20th. Why is this not my final answer? Right, 15 has to be changed to 1.52. Right, I can't have 15.2, I need to have 1.52. So two different ways you can do this. So the first way you can do this is to rewrite this in scientific notation. So rewrite in scientific notation. So if I was going to rewrite that first part in scientific notation, it would be 1.52 times what power? Or 10 to the... Okay, 10. This first one's 10 to the first. And then we still have our times 10 to the 20th on the end. So Kern said it's 1.52 times 10 to the 21st. Because you add your powers then. Now the other way you could do it is you could actually expand it out. You know, if you had 15.2 times 10 to the 20th, you could move that decimal place over 20 times and then move it back. So see how if you would move it over 20 times, how many times would you have to move it back to put it right there? 21 times, right? You see how that makes sense when you kind of think about it. So you wouldn't actually have to like move it, you just need to think about it. All right, so the next one. So I have 9 times 10 to the third over 3 times 10 to the second. So it's like, that's basically like I had 9 over 3 times 10 to the third over 10 to the second. I mean, with fractions, you can do that. Does that make sense? Like you just multiply across the top, multiply across the bottom. All right, so 9 over 3 is 3 times 10 to the first. Subtract your exponents. That's it. Now, if you had gotten something like 0.3, you would have to do that trick we just did. So you'd have to change that first part and then think about what it would be. Okay, so the next one, what's 5 going to be? 3 times 10 to the 5th. And 6 is 10 to the what? 12th, right? You subtract your powers. So you'd have 8 minus a negative 4. So that'd be 12. Okay. And the last one, there are about 5.10 to the 6th red blood cells in 1 milliliter of blood. A certain blood sample contains 8.0 8.32 times 10 to the 6 red blood cells. About how many milliliters of blood are in the sample? Okay, do we multiply? Do we divide? We divide. Okay, so it might make more sense if you think of like a real life problem. So if there are, I don't know, thinking of like gumballs for some reason. So there's 200 gumballs in one jar. So we're just thinking of it a different way. So 200 gumballs in one jar, and then a certain sample contains 600 gumballs. How many jars are there? That's the same kind of thing. Okay, so you're saying 8.32 times 10 to the 6th. You're going to divide by 5 times 10 to the 6th. The 10 to the 6th go away. So you need to find 8.32 divided by 5. What do you get? 1.664. So that's the number of milliliters of blood. So that's it. That's the last one, right? Yep.